Hi, everybody. Welcome back. So, in this video, we are going to talk about a couple sort of really important concepts that go together and are really sort of key to any kind of performance analysis that you're going to be doing on a system, and are just sort of things that you want to be thinking about that I think a lot of times people have a very basic understanding of, but don't really sort of put together. So that's going to be latency and concurrency and the relationship between the two. And then we might touch on a little bit about queue depth. And on top of that, we're going to talk about the best value upgrade that you could make to a computer, generally speaking. So, what we're going to go do is jump over to my desktop. So, there we go. And we're going to talk about latency. Right. So, step one is let's define our terms. Right. So, what is latency? Right. So, latency is basically equal to the time it takes to process a given unit of work in a system. Right. And I think what most people think it means is basically how long does it take for a ping to get there. Right. And that's not what it means. It means uh, what we're doing is we're sending an ICMP packet across the network and we're seeing how long it takes, right? So the unit of work is get there and then come back, right? So how long does that take? There's latency for accessing a web server. There's latency for reads from disk. There's latency for all sorts of different things, and that's an important thing to realize. Additionally, it's super critical to define the unit of work, right? So let's sort of take the basic example of network latency and using a ping to test it. So let's say your environment that you're looking at looks something like this, right? So you've got your machine, right? You're then connected to a switch. That switch is connected to a router, right? And this is going to go ahead and do natting, right? And then you're connected to the internet, and then you're connected to some destination system, right? So this is your source, this is your destination, or depending which way it goes, right? And obviously, if you're looking at it from the opposite, the other side is the source, and then you're the destination, right? So if you're going to be doing a ping and you're connecting to this destination system over here, what you're going to be doing is you're going to be sending a ping that goes to this switch, that goes to this router, that goes over some path on the internet, and then connects to that destination system. And then we go get the response back, right? So let's say this ping time took you, um, well, let's say, let me make it high. Let's say that this took you 30 milliseconds, right? So it took you 30 milliseconds to get to that destination, right? And, we'll just look at the one way, right? So we're not considering sort of round trip. So basically, got over there, you look at your time, it says 30 milliseconds, right? Now, let's say that you flip this equation and you ask the person on the other side to test this to see what their latency is and to confirm it, or you say, hey, I'm getting really bad latency. Can you check into this? And then they do a ping, right? So what they're going to be seeing, because this is natted, right? So this is your IP address that they're going to see. They're going to see the public IP address, whereas your machine is going to have some 10.10.10.55 address or a 192 address or something like that. But it's going to be an internal, right, IP address, whereas this one is public, right? So what's going to happen is when the destination is the source and they're going to go connect to you, what they're going to see as the destination is the router. So when they go do a ping, they're going to go do a ping here, and let's say for them that's 10 milliseconds. If they say, I don't know, the latency looks fine for me, they're right. It does look fine for them. And the reason why is because they're looking at a different thing. let's say, for example, this switch is broken, right? That's having some kind of problem, right? So this is where that extra 20 milliseconds of latency are happening, right? Well, they're not going to see that. So knowing the sort of latency is really useful, but only knowing it in context, right? That's the part that actually matters. So when you're trying to go troubleshoot something, you want to make sure that you're looking at the piece of the equation that is actually useful. So, all right, latency is super important. So the next thing that's worth noting is when we're looking at latency, for most things, it's actually broken up into two pieces. So latency, we generally sort of think of the amount of time that it takes to complete a unit of work. Well, that's actually not specifically true. It's the amount of time that it takes for a unit of work to be completed, right? And that sounds like the same thing, but they're actually two separate ideas. Because let's say we'll just take this out of tech completely. Let's say, for example, you are at the grocery store and you're buying some groceries, right? So you're in line, and there's the cashier, right? And you get your sort of little dividers over here, right? We've got the one person who is being checked out, give them some feet, and we get our cashier over here, right? Who's doing the checking up, all that kind of stuff. And then you have, these other, let's say, three people in line, right? So if this is the unit of work that we're looking at, we are looking at the wait time and then we are looking at the service time, which are two completely separate things. So let's say, for example, on average, it takes this checkout 3 minutes, right? Well, if we have three people in line, right, and we are assuming they're all average for this this scenario, well, we have 9 minutes of wait time, and then we have the additional 3 minutes that it takes to actually check that person out. So here we're going to have a total of 12 minutes wait in line, right? So another way to go say this is that the amount of time in queue is going to be 9 minutes, right? So the queue is basically the buffer or the people in line or whatever it is that's not being serviced, right? So when you're looking at a system and you're trying to go ahead and deal with some performance issue, right? Well, what you generally have sort of two knobs that you could try to go adjust. You could try to go ahead and speed up your service time, or you could try to go ahead and reduce the wait time, right? Now, service time oftentimes is fixed. Now, sometimes you can go change that. So, like, let's say, for example, we're looking at storage, right, or processing, computations, right. In those scenarios, we could move from hard drives, let's say, to an SSD, and that would speed up our service time, generally speaking, right. Same thing with CPUs. We could go from an older CPU to a faster CPU. But if you look at things these days, Moore's law is basically done for, right? We're not seeing a huge advance in CPU speeds, at least not in the last 5-10 years. It's more or less sort of leveled off, and we're probably going to get some speed increases, but it's not the same kind of doubling every couple of years that we used to see. So the other side of it is wait time, and wait time we can go ahead and have a very big impact on with concurrency. Right. So concurrency is basically how many things can you process at once. So if we go look at this, right, well, we have 75% of the amount of time that we're going to have, out of our latency here, going to be comprised of wait time, and only 25% going to be of the actual service time. So if we can go ahead and reduce the wait time, that's really, a very useful thing, because we could potentially, save a lot of time in this example. And the other thing that's great about the wait time is very often we can do that, right? So that's a much easier knob to turn quite often. So what we might be able to go do is open some more registers, right? So if we go open up some more registers, we get another one over here, another one over here, another one over here, right? So now we have a number of services, number of things that can serve, in this case, cashiers, customers, equal to the number of items in queue, right? So the issue is that if at this point we then go add some more registers, there's no value to these, right? So these have zero value, right? So one of the important things to be able to understand is how big is your queue, right? So that's one of the things that's very useful to be looking at when it comes to managing systems, either from an operations side, a DevOps perspective, where you're going to be doing a lot of sort of tuning and deployment to sort of adjust things. This is where elasticity in cloud-based services really comes into play, is dealing with your wait time, right? But if you spin up another instance of something, well, you're going to get charged for that. So it's really important to understand where your zero value point is, right? Where the tipping point is, and you're not going to get any more benefits from adding more instances, right? So you can measure that just by how much does your latency go down? Does it continue to drop? That's one way to go do it. Or if you know what your queue is, right? If you're keeping track of that, and that may be something that you want to go do as an application developer if you're writing code, that can be very handy, right? So that brings us to the cheapest and probably best value upgrade that you can make on a computer system for most people. Now, this is a bit of a caveat here. So this is going to be desktop systems generally. So not so much with laptops, although some laptops, if you get like a ThinkPad, for example, you can go do this, is just to go add a second disk, right? So this especially was useful with hard drives, but still with SSDs, especially as SSDs get bigger. One of the things that a lot of people don't realize is that if you've got, let's say 10,000 ops for a given SSD, maybe a low-end SSD, now as these things are getting bigger and bigger and bigger, once you get up to the multi-terabyte range for SSDs, well, the ops you get per gig, right, if you're looking at it that way, kind of comes down a lot. So yeah, anyway, getting back to the best upgrade that you can go make, which is to take, instead of just your one drive, get a second drive, right? That's it. That's the best value upgrade you can make. It's really, really cheap. You go look on Amazon, prices for SSDs now are really, really low. If you're doing this on hard drives, this is even better. You're going to get a lot more value, from that, because you can then go ahead and spread your data across both of these disks. Right? And you can do this. You could either do this as a mirror, or you could do this as sort of a JBOD and just do striping across both of those guys. Either one will work nicely, but you get your SSD 1, you get SSD 2 down here, right? And you're going to go get a lot more I/O. So the reason why this is such a big value is because the return on investment initially is going to be very, very, very high. So if we go ahead and look at a little graph, on one axis we have time, and then on the other axis we have units of concurrency. In this case, it's going to be disks, right? If we go ahead and have one drive and we're reading and writing everything to one drive, we're going to get the max number of I/O that we get from that one drive, right? If we go ahead and add a second drive, well, all of a sudden we have very high concurrency. So basically we can go ahead and break up 50% of our reads and writes and give them to each drive. Same idea as opening a second line in the grocery store. So if you're looking at sort of a automation kind of thing, generally what's probably a good idea is to very quickly spin up a second instance of something. So let's say you get a web server or a database server that's serving a bunch of clients. Anytime you start to see any kind of load at all, any kind of latency at all, it's probably a good idea to go spin up a second instance, right? Because there's really high value for that. The return on investment is massive. You basically just dropped the amount of time that you're going to go ahead and serve each request on average in half, because you've dropped the wait time in half, right? So that's basically 2 units, right? So if we go from 1 unit to 2 unit, if we go ahead and do 4 units, So I'm jumping ahead a little bit here. If we go to 4 units, right, well, we're going to go ahead and divide that in half again. So still very useful. We've dropped our wait time down significantly, but we're getting less return on investment here, right? Because it's having less of an impact, right? So this is the, the total latency that we have, basically, effectively, because time is the amount of time it's going to take to complete the unit of work. So this is also viewed as latency, or at least the wait time, right? So we might have a little additional bit, which is our, our service time, right? And all this is our wait time, right? So if we go ahead and want to get the same kind of performance doubling again, well, we're not going to just have to add one more disk. We're going to have to go add another 4 disks. So we're going to go up to 8 drives, right? Then we're going to go ahead and see that again. And basically, this is just going to be a doubling, from every single, point forward. So we're going to go to 16 and then 32 and, 64 and 128 and 256 and that whole kind of thing. But the idea is every single increment that we do, we're going to get less and less and less benefit, right? So that's the biggest upgrade that you can go ahead and make on your home machine is just go add another drive. It's really cheap. You can always just go mirror it, right? It may not be the most optimal way to do it for everything. Striping might be better, but if you already get an existing, drive, you don't need to worry about laying things out too differently. You can just turn on mirroring in most operating systems. So that's definitely something to think about. So anyway, that's really kind of common thing that kind of comes up when it looks at performance analysis stuff. It's sort of looking at the different tools you're going to use to measure those things and sort of how those fit within your system. I think in another video we'll talk about Little's Law, which is a way to go ahead and sort of figure out what your sort of optimal queue depth is going to be, and what your average queue depth is probably going to be. And then if you know your queue depth, you could go figure out your ops or your latency or your arrival rate and your latency, depending on how you want to go look at it. So maybe we'll talk about that in another video. It's a handy little formula. It's the simplest little formula you ever come across, but probably good to sort of break that up across multiple videos. So anyway, thank you guys so much for watching. Hopefully this was useful for you. If you enjoyed this video and you like these kinds of conversations and topics, feel free to go ahead and subscribe. Give the video a like. Comment down below if you think that there's other really interesting things that sort of impact performance and latency or otherwise to kind of, if you don't agree that adding a SSD or a hard drive as a second item is the probably best value for money upgrade you can go make on a system, throw that down below, because I if I'm wrong on something, I always appreciate learning otherwise. So thank you guys so much. Have a great rest of your day, and I'll see you guys in the next video on Sunday. Cheers.